Hello guys and welcome back to Easy Stats with Danny and I'm sorry to be posting uh this late. So the thing is I had some issues and I was also busy with other things. However, you don't have to panic a lot about study unit 5. So there's only one question, like literally one question they can ask from the entire study unit. However, we want to understand first what is actually study unit 5. Study unit 5 is called practical significance. So basically they'll give you questions about hypothesis testing, and then from there they'll ask you about practical significance. Like for example, before we do the question paper that you see on the screen here, practical 5 is basically whereby we carry out a whole hypothesis test, and then after we want to test if there's the difference in the test that we tested, we just did, and the main claim that we have. Like for example, if let's say we are claiming if a certain pill can cure a certain illness, and then we test that maybe using a couple of patients and all that. After that, we're making a conclusion that okay, we have enough evidence to say that this pill can actually solve this problem. And then from there, we want to test the difference. So that is where practical significance comes in. We want to test if there is a difference in from the test that we just did and the main claim that we had. And then from there, we want to know if we can actually prescribe that as the formal cure for that particular disease. So that is all what practical significance is all about. Now, when it comes to numbers, it's always different. So we're going to use some calculations as well, and also how to interpret that. I'm just going to show you guys just now with this question. It says here, a traffic officer claims that motorist exceeds the average speed limit of 80 kilometers per hour on a certain public road. The average speed of a random sample of 52 motorists is recorded as 83 kilometers per hour with a standard deviation of 8.45 kilometers per hour. Is there enough evidence to prove the traffic officer's claim at 1% significance level? Assume that the average speed motorist drive is normally distributed. Now they'll ask you questions about hypothesis as normal. They'll say formulate the null alternative hypothesis. You know that it's one population. We're just gonna say mean null hypothesis equals to 80. The alternative hypothesis is going to be uh, greater than 80 because they said exceed. Then you calculate the suitable test statistic. You know how to do that. We did it in study 3. And then they give you the p-value. You make a decision and draw a conclusion. Now they'll ask you about the suitable effect size. Now they say calculate the suitable effect size that can be used to test whether there's a practical significant difference between the average speed limit and the results from the sample. What conclusion regarding the initial problem can be drawn from this? So basically here, this is the only question about studying 5, the entire studying 5. This is the only question. Sometimes they can just say calculate the suitable effect size and interpret the magnitude. Now, this is actually how you're going to calculate it. There's a formula called the Cohen's D effect size formula. So the D is equals to absolute value of x bar minus the main claim over the standard deviation. So these lines here are called absolute values. And then when you go to your compute the a calculator, I'm just going to show you how you do that. You go to your calculator, and then on the calculator, what you're going to do is you're going to say fraction, and then you're going to say ABS for the absolute value. The reason for this is our answer for the Cohen's d effect size has to be positive all the time. Now with this kind of question that we have here, we're going to say 83, which is the actual mean according to this actual mean minus the main claim. So it's going to be 83 minus 80, and then you're going to say divide everything by 8.45 because it's the standard deviation, 8.45. Now after this, you say this is equals to, the answer that you get here was 0.35. Now 0.35, this is the guideline for both one population and two populations. We're going to do two populations immediately after this so that you guys can see that. So because this number is 0.35, our guideline says if it's approximately 0.2, it's a small effect, practically non-significant difference. And then if it's a 0.5 approximately, it's a medium effect, practically visible difference. And if it's 0.8 or larger, it's a large effect, practically significant difference. Now, there may be cases like this case whereby you find your d effect being equals to 0.35 or 0.36, you round off to 2 decimal place. Now in that case, you can see it's clearly not 0.2 and it's not 0.5, it's in between. And in 0.35, it's actually quite exactly in between, 50% in between or something like this. So it's between these two. Now, if that is the case, then you're going to say it's a small to medium effect. It's a small to medium effect, which means it's practically non-significant to practically visible difference. So that's how you actually write it. It's a small to medium effect. Therefore, it's practically non-significant to practically visible difference. Now, if the answer was actually 0.8 or it was 0.9 or even more than that, then you're going to say it's a large effect, practically significant. If it's 0.47, 0.48, 0.5, 0.52, it's a medium effect. And then if it's a small effect, it's 0.2, maybe 0.23, maybe we can say up to 0.27, 0.28, somewhere there, because it's still approximately and it's closer to this compared to this one. So that's how you actually interpret it, and that's how you make that conclusion about the initial problem. Now let's go to question 4 of another question paper. So this one was an example of two populations. So in the two populations, I wrote the formulas here for you guys to see. So it says here, a market researcher in Johannesburg claims that the average salary of residents of Saxonwold is more than the average salary of the residents in Hyde Park. Two independent samples were taken in each neighborhood, and the sample information was as follows. So you have your sample sample size, you have the mean and the standard deviation for Saxonwold as well as for Hyde Park. Now, the question they will ask is always, like I said, they will start with hypothesis testing questions. First question will say state the null and alternative hypothesis, and the second question will come and say calculate the test statistic, and then they'll give you the p-value, and then they'll say with the p-value what decision and conclusion can you draw from that, and then after that they will ask you for the effect size. So now when you have that information, you do the same. You press the fraction and then press the ABS, is the absolute value. In this case, we're going to use the mean bar one, which is 1.1 million. So it's 1,100,000 minus 1,005,000, everything divided by 200,000. You say equal. The answer that you get here is 0.48. So 0.48, you can clearly say that it's actually closer to 0.5 than just say it's a medium effect, practically visible difference. That is how you actually interpret the value there. Now let's say one of the sample sizes was small, or one of the sample size, or both of the sample sizes were small. So if one or both is small, then this is the formula that you use. You know that if one of them is small, then you calculate using SP. If you don't know how to calculate SP by now, it is a problem. You must go back to the study unit 3 and then know how to calculate your SP. If let's say for example N2 was 23, then you have to calculate the value of SP, and then you're going to use that SP, you substitute here, and then you say x bar 1 minus x bar 2. The reason why we use 200 here, it says S max. I just forgot to explain that. It says X max. So you take the standard deviation that is actually higher when you have two populations that are both high. You see here, we took divided by 200,000 because 200,000 was actually more than 150,000. So the standard deviation for this was higher than for this. So that is why we actually did it over there. Now the interpretation is the same. It's there in the slides. You can just go and check it when you write as well. It's a small effect if it's 0.2, approximately 0.2. It's a medium effect if it's 0.5, and it's a large effect if it's 0.8. It won't be the exact number, but then you check the one that is closer, like it says approximately. Even here we said 0.48. It's closer to 0.5 than 0.8 and 0.2. So hence we say it's a medium effect, practically visible difference. And that is all about study unit 5. That's the only question they can ask from the entire study unit. So otherwise, you guys shouldn't panic much about it. It's basically going to be 3 marks maximum. The maximum of study unit 3, study unit 5 in the paper is like 3 marks on each question. If they ask maybe for 1 and 2 populations, then it's going to be 3 for 1 population, 3 for 2 populations, which I doubt. I think they're going to ask it on one, maybe 2 populations or 1 population. So it's going to be less than 7 marks for sure in the whole question paper. So yeah, that is study unit 5, and yeah, I just wish you guys all the best. I'll see you in the next video.